the sun for billions of years while the sun is constantly losing this mass and losing its gravitational pull. To me, that invokes the miracle. It's much simpler to say the system is not billions of years old like they're telling us. God created everything about 6,000 years ago exactly like the Bible says. Okay, what about carbon dating? Every seminar I do, somebody will say, wait a minute, carbon dating proves the Earth is millions of years old. Oh, no, it doesn't. The fossils are actually dated by their position in the geologic column. We cover that in seminar part 4. And the geologic column does not exist any place in the world. Radiometric dating would not even be possible if the geologic column had not been erected first. Article in American Journal of Science magazine talked about this. Ever since William Smith at the beginning of the 19th century, fossils have been and still are the best and most accurate method of dating and correlating the rocks in which they occur. Apart from very modern examples, which really are archaeology, this guy said, I can think of no cases of radioactive decay being used to date fossils. So they don't date fossils by carbon dating or potassium argon dating. This is a mammoth tooth. They date them by the geologic column. They pick a spot and say, wow, that era was, so many thousand years ago, and so this must be that old. Fossils are not dated by carbon dating. But let me explain how carbon dating works. The Earth's atmosphere is about 100 miles thick. On this globe, it doesn't even show up. I mean, it's the thickness of the paint, basically. 100 miles is not much. The space shuttle whizzes around just above the atmosphere, so it cuts down on drag, and they can get no friction up there. Still get lousy gas mileage, though. The air, 100 miles thick, is mostly nitrogen. 78% nitrogen, 21% oxygen, 0.06% carbon dioxide, and that's what plants breathe, CO2. Some people say 0.09 or 0.03, I don't know, it varies, I'm sure, location to location. But there's not a lot of CO2 in the air. If you increase CO2, plants grow faster, which is a frustration for the environmentalist wackos when they burn forests, all the CO2 is released and the trees next door grow faster. So it doesn't create an environmental crisis like they want you to believe. There's extremely small quantities of radioactive carbon-14. The way this works, radiation from the sun strikes the atmosphere, super high-speed energy comes down, bangs into the nitrogen, and changes it to carbon-14. Just a quick, simple chemistry lesson here. Carbon and nitrogen are right next to each other on the periodic table. Nitrogen is number 14, carbon is number 12. But if the nitrogen gets blasted by radiation, it turns into carbon-14. Normal carbon is called carbon-12. Here we have what's called radioactive carbon, carbon-14. It's very rare, and it doesn't stay stable because it's always breaking apart. You can hear it with a Geiger counter. In the movies, they got the Geiger counter getting by the uranium and going click, 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 click. Well, the same thing with carbon-14. It breaks apart. It's falling apart. And it's turning back into nitrogen and disappearing, which is a gas. It disappears into the air. Carbon-14 is produced in the atmosphere by the sun. It breaks down at the rate of about half of it will break down every 5,730 years. This is called the half-life. So if I gave you a pile of carbon-14 and you waited 5,730 years, half of it would turn back to nitrogen and you'd end up with half a pile. If you wait another 5,700 years, half of that is going to turn to nitrogen. You end up with a fourth of a pile. In theory, it never goes to zero. It goes from half to fourth to eighth to 16th, etc. But plants are always breathing in carbon-14 in the photosynthesis process. They're breathing in carbon. Some of it's carbon-14. Most of it's normal carbon-12. Animals eat the plants and make it part of their body. Probably during your lifetime, you've either eaten plants or you've eaten animals that have eaten plants. That's about all there is to eat out there. And so you're absorbing radioactive carbon into you, just like I am into me, because we're getting it through the food chain. The plants got it from the air got it from the sun. This carbon-14 got into the plants, then it got into you or into the animals and then into you. But either way, we all contain some radioactive carbon. When the plant or animal dies, it's not going to get any more, obviously. So several assumptions are involved in carbon dating. First of all, they assume that the amount of C14 in the atmosphere, the ratio, which is a very small number, is the same found in the plants and animals. For instance, the atmosphere contains 0.0000765% radioactive carbon-14. It is assumed that I have the same. I've never been tested for C14 and I've never met anybody who has. But I would say that's a reasonable assumption, but it is an assumption. Okay. When the plant or animal dies, it doesn't get any more C14, so whatever it had begins to decay. It was decaying while it was alive, but you never noticed it because it's being replenished, so the balance would stay. But as soon as it dies, it begins to go out of balance. So basically, carbon dating is measuring the amount of carbon in the object with the amount of carbon in the atmosphere and getting a balance. If the atmosphere is 0.0000765% and the object you're dating is only half as much, they would assume it's been dead for 1 half-life. If it's only 1/4 as much, it's been dead for 2 half-lives. 2 times 5,730. And then it goes to a 4th, to an 8th, to a 16th. So they're comparing the amount in the object with the amount in the atmosphere. This is how carbon dating works. Sounds good, certainly sounds scientific, but it's based on some serious assumptions that mess up everything. It doesn't work. If I told you to fill a barrel with water, but I have drilled holes in the barrel, while you're putting water in, it begins to leak out. So you have a process of filling and a process of leaking at the same time. You have an adding and subtracting going on simultaneously. At some point, you're going to reach a stage called equilibrium. You'll never fill the barrel past that point unless you speed up the input or decrease the outgo, one or the other. Well, Earth's atmosphere is constantly taking in carbon-14 from the sun, and it's constantly losing it to decay. So you have the same thing as the barrel. The question would be, how long would it take the Earth's atmosphere to reach equilibrium? Well, when carbon dating was first discovered or invented in the early 1950s or late 1940s, actually, Willard Libby did this, University of Chicago. He said, I wonder how long it would take the Earth's atmosphere to reach equilibrium, because he knew about the equilibrium problem. They said, after doing some studies, it would take about 30,000 years. Basically, if you made a brand new planet Earth, poof, create one, cover it with air, start it spinning around itself and spinning around the sun is going to strike the oxygen, strike the atmosphere and produce carbon-14, and it's going to start decaying. And they said within 30,000 years, the atmosphere would be equalized. You'd reach this point called equilibrium. You're never going to get more C14, and you shouldn't get any less unless something changes in the system. Well, sounds good. I don't know if the number's right, but the concept is. Within 30,000 years, the Earth's atmosphere would reach equilibrium. The problem is, we still haven't reached equilibrium. There's more C14 now than there was 20 years ago. Actually, radiocarbon is forming 28 to 37% faster than it's decaying. So if we still haven't reached equilibrium, then the Earth is less than 30,000 years old, which is what the Christians have been saying all along. A friend of mine has a website, archy.org. You can get information there about Earth's atmosphere has still not reached equilibrium. There's been a lot of people doing research on this, and we're not there yet. This chart indicates how carbon-14 is supposed to work, in theory. An object that is still alive should be in balance with the atmosphere, which would give you 16, I'm going to simplify this a little bit, give you 16 clicks per minute per gram on your Geiger counter. If you're listening to testing a sample, it'll go click every 4 seconds, click, click. If it's only giving you 8 clicks per minute, then you're assuming it's 5,700 years old. It's been through 1 half-life. If you're only getting 4 clicks per minute, it's been through 2 half-lives. If you're getting 2 clicks per minute, it's been through 3 half-lives. It's 11,000 years old. This is how carbon dating is done. If you test a sample and you find out you're getting 2.5 clicks per minute or 2.9 or something like that, you look at the chart and read over and find the age by the simple calibration curve, they call it. Sounds good. Doesn't work. If you walked into a room and found a candle burning on a table, and I asked you the very simple question, when was it lit? You say, I don't know, it was burning when I got here. Okay, let's do what's called empirical science, things we can test and demonstrate and weigh and prove, okay? We're going to measure the candle. We measure the height of the candle. We find out the candle is 7 inches tall. Okay, when was it lit? You say, I don't know. Okay, let's do some more science. Let's measure how fast it burns. Suppose we get an Olympic stopwatch and we measure this thing very carefully and find out the candle is burning 1 inch every hour. Now we've got 2 hard science empirical facts. The candle is 7 inches tall. It is burning 1 inch an hour. When was it lit? You still can't tell me unless you make some assumptions. How tall was it? And has it always burned at the same rate? Neither of those assumptions can be proven. They are purely